Hey everyone, today we're going to talk about another new data type called Booleans. And to best understand these, let's continue looking at the example we took a look at last time. So imagine we're logging into a website and we see a screen that looks just like this. We enter our email, our password, and then we press the login button. And what happens next is a computer somewhere behind the scenes is going to actually receive this email password combination. It's going to evaluate it and then it's going to make a decision. It's going to say this person can log in or this person can't log in. Yes or no. There's no such thing as maybe this person can log in. And whenever we have a decision like this, where it's clearly one thing or the other thing, that's a signal that Booleans are being used or should be being used. Because that's really what Booleans are. They're used to represent the outcome of true or false decisions. And like with most things in programming, the best way to really understand them is to just start looking at some examples. So let's start by taking a look at the keywords that Python uses to work with Booleans. Booleans have two possible values, true and false. Now, like we've seen with other data types, the fact that these keywords become highlighted and the Python shell mirrors what we typed back at us are both signs that these true and false keywords actually mean something. So Python understands what we're typing here. And the capitalization that we use actually matters. So you'll see that I started true with a capital T and false with a capital F. If I had tried something like this, I would get back an error. And that's because Python is something called case sensitive. And case sensitive basically just means that the capitalization we use matters. So in Python, the word true with a capital T and true with a lowercase t are not the same thing. Similarly, if I had written true with a capital R, this is also completely different. So anytime we change the capitalization, it means something entirely different to Python. Python understands this word, but none of the others. Now, you'll see that when I typed true with a lowercase t, we actually got a name error. And in the past, we've only seen syntax errors. Now, the full difference between these two errors is a bit nuanced, but a good way to think about it is a syntax error occurs when you write a line of code that doesn't make sense to Python. In other words, the entire line just doesn't follow Python syntax. If I had tried true, false, like this, when Python tries to read this line, it's just going to see two words that it doesn't recognize and a space in the middle. And it's basically just going to say, hey, the overall structure here or the syntax of this line doesn't make sense to me. I can't even start to try picking it apart. Whereas if I had just written true, Python looks at this line a little bit differently. It says, okay, there's a single word, so the syntax of this makes sense. I can handle a single word. But then when I try to actually make sense of that word, I get a name error because the word or the name, Python calls these names, isn't something that I understand the value of. So we know what keywords Python uses for Booleans. That's true and false. And we know that Booleans represent these very rigid true or false decisions, where it has to be one thing or the other thing. Now we're going to take a look into how to actually ask Python if something is true or false. For example, say I wanted to ask a question like, does one thing equal another thing? And we can do that using the double equals operator in Python. So this operator has special meaning in Python. When we use it, it's going to take whatever's on the left side, say I put 1 here, and whatever's on the right side, and answer the question of, does the left side equal the right side? So this says, hey, is 1 equal to 1? And that's true. So it gives us back the value true, which we now know is a Boolean. Now, if I had changed one of the sides of this equation, and I asked, hey, does 1 equal 2? As expected, we'll get back false. And you'll notice that I'm using ints here. Ints are a data type we learned in a previous video. But we're not constrained to using ints. We can try this with strings as well. So let's try asking, does hello equal hello? And as expected, we get back true. Now, an interesting thing about strings is that strings are also case sensitive. Just like how we talked about the keywords we use in Python are case sensitive, capitalization also matters for strings. So if I change this line to say this, now we get back false. And that's because when Python evaluates this, it sees that lowercase e is not equal to capital E. And at this point, since we've done ints and strings, we can also try with floats. Now, the double equals sign that we just looked at is an example of a comparison operator. And in Python, there are 6 comparison operators. So double equals checks if 2 things are equal. Exclamation mark equals means not equals. So this checks if one thing is not equal to the other thing. The less than sign, similar to in math, means is one thing less than the other. This is how we say less than or equal to. This one, again, just like in math, is the greater than sign. And this one is greater than or equal to. So that's a lot of new information. Let's take a look at how each of these worked. We've already used double equals, so now we're going to start looking at not equals. So if we took hello equals hello and changed this to not equals, we should get back false. And that's because this really says, does hello not equal hello? And since hello does equal hello, this will evaluate to not true. Now, if we change this to use 2 things that actually are not equal to each other, now we're saying, is hello not equal to hello? And we get back true. Another sign we went over was the less than sign, so I can say is 1 less than 2. And if I change this to something that isn't less than another thing, so I can say is 2 less than 2, then we should get back false. So as you can see, a lot of this is pretty intuitive. Python's really designed to work with things that we already know. So if you know these signs from math, you're going to be able to apply these in Python pretty easily. So if we wanted to change this statement to be true, we would say less than or equal to. And remember, this is the symbol in Python for less than or equal to. And similarly, we can try this with greater than. This should be false now. And we can try the same thing with greater than or equal to, which is true because 2 is equal to 2, so it is greater than or equal to 2. And one other interesting thing you can do is actually use these operators on strings. So we can say, is A less than B? And when you're using this on strings, what this really means is, does A come before B in the alphabet? So really it just does alphabetical order. And of course the answer is yes, so we should get back true. And this works exactly like a dictionary does. If I change this to, is animal less than zebra, we get back true because animal starts with an A, so it comes before zebra in the alphabet. And you can do this exact same thing with any of the comparison operators we just went through. We're not going to go through every single one right now, but this is a good exercise to do if you're following along. Pause the video and try out a couple examples and see if you can understand why Python's giving you the results that it does. At this point, we've learned 4 data types: ints, floats, strings, and booleans. And Python actually has a built-in way to help us tell these different data types apart. So say we have the value true, which we now know is a Boolean. We can actually ask Python, what is the type of this? And we would expect it to tell us that it's a Boolean. The way that we do this is with a special keyword called type. And type syntax is a little bit different than what we've seen so far. So when you're using type, you write out the word type, you put a set of parentheses, and then you put the thing that you want to know the type of inside of these parentheses. So in our example, we want to know the type of true, and we would expect back the value Boolean. And Python does give us back bool. And bool is just short for Boolean. These things mean the exact same thing. But it also gives us back something else. It gives back this word class. And class is really just a type, and since the only type we've learned so far are data types, we can interpret this entire line as saying the data type bool. Now, if it's the first time you're seeing something like this, where we did type, parentheses, true, and parentheses, this probably looks pretty confusing. A good way to think about it is to start with the overall meaning of the line. So what question are we trying to have answered here? Well, we're really asking Python, what is the type of true? So that's kind of the English translation of this entire line. What is the type of true? And now all we need to do is take what we want to know in English and translate it into Python. And that's exactly what we did right here. So the way we ask Python what is the type of true is by putting this type keyword, then opening a parenthesis, putting the thing we want to know the type of next, and then closing a parenthesis. Now the reason type has this strange syntax that we haven't seen before is because type is something called a function. And functions are really cool. We're going to learn a lot more about them in the future. But for now, all we need to know is that a function is something that takes some input and gives you back some output. So in this example, the input we're giving type is the value true. And then the output that type gives back is the data type bool. And that's really it. It's easy to overthink this and get very confused when you see the syntax for the first time, but all that's happening is we're asking Python, what is the type of true? And we can do this exact same thing not just with Booleans, we can do it with other data types we've learned as well. So we try the same thing and use an int, we get back int. If we try it and use a float, we get back float. And probably like you're expecting by now, we can also do this with a string, and we get back string. And another thing to point out here is str is the abbreviation that Python uses for strings. So the data type here is a string, Python uses str, just like the data type here is a Boolean and Python uses bool. So that's going to wrap up our introduction to Booleans in Python. At this point in the playlist, we've learned the core basic data types that we need. So moving forward, instead of learning a new data type every time, we're going to start to build programs that use the data types we already learned to do more interesting stuff on top of that. If you found this video helpful, please leave it a like and subscribe. And as always, thank you for watching, and I'll see you in the next one.